This question is to find specific values for a continuous random variable given its probability density function. A continuous random variable, called x, has a probability density function defined as follows. It equals 1/3 when x is between 0 and 1. It equals 2/9 when x is between 3 and 6. And it is 0 everywhere else. Find all the values of k such that the probability that x is greater than or equal to k is equal to 2/3. First step is to translate the probability condition. We are given that the probability that x is greater than or equal to k is 2/3. That means the probability that x is less than k must be 1 minus 2/3, which is 1/3. So, we are looking for the value of k where the total area under the density curve from -infinity up to k equals 1/3. Next step is to examine the structure of the density. Let's analyze the shape of this distribution. Between 0 and 1, the density is 1/3, so the total area from 0 to 1 is exactly 1/3. Between 3 and 6, the density is 2/9, and the length of that interval is 3 units, so the area is 2/3. There's a gap between 1 and 3 where the density is 0, meaning it contributes nothing to the total probability. So, all the probability is concentrated in just 2 segments, 1/3 in the interval from 0 to 1, and 2/3 in the interval from 3 to 6. Next step is to solve the equation. To find where the accumulated area equals 1/3, we only need to go from 0 up to some point inside the first interval, or possibly into the gap between 1 and 3. Now, from 0 to 1, the area already reaches 1/3. And since the density is 0 from 1 to 3, moving further into that gap does not increase the area at all. Therefore, any value of k between 1 and 3 will still give a total probability of 1/3 when integrating from the left. So, the set of all such k is the interval from 1 to 3, inclusive. This is the final answer. A common mistake is to forget that zero-density intervals add no area, even if they're long. Always pay attention to where the density is actually non-zero. When solving for a threshold using a probability density function, think in terms of area under the curve. Look at how far you need to go left to right to accumulate the required probability, and skip over any zero-density gaps. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much.